All right, we are almost done with 22.2. We're just looking at number 4. And number 4 is kind of putting all of it together that we've talked about in numbers 1, 2, and 3. We want to write an inequality. So let's refresh our memory. Our equation from before was $3, right, per square foot for gravel. And then it was $15 per square foot for artificial turf, and her budget was $3,000. So this is our equation, but now this question number 4 wants us to actually write an inequality that represents the constraints in this situation. We want to explain what the solutions mean and show the solution region. So in our graph over here, we've discovered that everybody in region 1 was over $3,000, which is not good because if it's over $3,000, she went out of her budget. But everybody in region 2 was actually under $3,000, which is totally fine. And in problem number 1, we talked about how the line actually represents exactly $3,000. So every point on this line is exactly $3,000. So with that in mind, I know that I'm okay with everybody in region 2. Everybody under this line is going to be a solution to my inequality. And I'm also going to take any point on the line because that means I spent $3,000. I'm actually not going to graph below the x-axis because if I go below the x-axis, that means that y is negative, and since y is representing turf, I don't care about anybody below the x-axis. I'm also not going to go to the left of the y-axis. I don't care about anybody in that region either because that means my x is negative and there's no such thing as buying negative gravel. So really this triangular blue shape that I colored is pretty much the solution set for this inequality. So I want my 3x, I want my grass plus my artificial turf to be less than, below, or equal to $3,000. And that is the inequality for this situation.